This coldest U.S. Air Force base becomes a most difficult arena in the icy grip of winter. Operating billion-dollar aircraft in challenging conditions is a difficult task for crews. Every takeoff and landing is a triumph over the frigidity of the Arctic. How do crews meticulously maintain runways and aircraft in prime condition at this freezing Air Force base? Join us to witness the most expensive aircraft ever built and experience firsthand how staff overcome challenges and go above and beyond to make operations successful. Don't forget to like and subscribe before exploring the coldest U.S. Air Force base. This sub-zero challenge serves as a testament to both the tenacity of nature and the unwavering dedication of staff weathering the storm with a steadfast commitment. Crews tackle snow accumulation head-on, sweeping runways non-stop to ensure safe takeoffs and landings. Although repetitive, this task is essential for keeping a runway in good condition even in the face of constant snowfall. Maintaining the best possible condition for aircraft in these freezing circumstances is equally demanding as runway upkeep. The crucial task of clearing snow from wings, windscreens, and the fuselage intensifies routine tasks. This is not just a routine, it's an important safety precaution to keep everything flying smoothly. Operating an aircraft in heavy snow conditions is dangerous. It also presents a significant risk to the crew's safety and the aircraft's overall performance. Because of this, it is important that every aircraft be cleared of snow and ice prior to takeoff in these severe winter conditions. The process of dicing, which is essential to maintaining runway and aircraft safety, is an integral part of the operation of this Arctic-like Air Force base. Dicing includes carefully clearing surfaces of snow, ice, or frost. In addition to removing these elements, anti-icing is a key technique. Applying specialized chemicals in order to keep surfaces clear and working smoothly will not only melt away existing ice, but also temporarily stop it from forming. The various dicing techniques can be adjusted to suit various requirements. Mechanical methods like pushing and scraping, applying heat, and using chemicals like salt, brines, alcohol, or glycol all play a role in lowering the freezing point of water. Certain approaches are carefully combined in certain methods to maximize efficiency. This procedure is essential for the aircraft itself as well as the runways, guaranteeing that they are safe and clear for aviation operations. Maintaining optimal performance and safety in an aircraft requires dicing its body. This becomes super important in situations where a small layer of ice can have a substantial impact on the aircraft's systems and aerodynamics. Following the dicing process, the next step is friction testing, which is crucial to ensuring runway safety. To evaluate whether a runway is suitable for aviation operations, specialized vehicles fitted with testing kits measure the amount of friction on the surface. This vital step determines decisions regarding additional dicing requirements and runway usability. Maintaining safety in the harsh winter climate is a must for year-round operations at this Arctic facility. The cooperation between the Office of Polar Programs of the National Science Foundation and the Cold Regions Lab of the U.S. Army Engineer Research and Development Center is a prominent example. This collaboration led to a groundbreaking runway design for Antarctica. Compaction was used in the design to strengthen the snow's foundation, according to Terry Mendy, CR Research Civil Engineer. This produced a surface that was sufficiently solid to hold large airplanes like the C-7. The creative project took more than 16 months to finish. It was the product of tight coordination between the Air Mobility Command and the NSF, demonstrating a noteworthy development in Arctic aviation technology. Operating year-round in these huge Arctic and Antarctic regions is a sign of human creativity and resiliency, not merely a logistical barrier. Getting through these icy areas requires a range of duties. These include making accurate plane landings on snow-covered runways, unloading necessary supplies with ease, and launching operations quickly. The LC100 Hercules, a ski-equipped Lockheed C-130 Hercules expressly developed for polar missions, is an important player in these operations. The harsh conditions seen in the Arctic and Antarctic are specially designed to withstand them. They are flown by the 109th Airlift Wing of the New York Air National Guard, making them the eyes in the sky for missions and in extreme conditions. Their sturdy design and capacity to land on snow and ice make them essential for moving people, supplies, and equipment through these harsh, isolated areas. Each successful landing and deployment highlights the operational capability and strategic significance of these specialized aircraft. They serve as the year-round backbone for important missions. One of the LC130 Hercules' crucial tasks becomes apparent when it gently touches down on the snowy runway. Deploying snowmobile units. These specialized vehicles are easily removed from the aircraft. They are necessary for movement in the snow-covered areas. In situations where conventional cars equipped with winter tires are insufficient, snowmobiles emerge as the linchpin for efficient ground operations. They can move quickly across the snowy terrain thanks to their sturdy construction and agility. This makes them useful for a variety of jobs, like emergency response and transportation. A lot of training exercises are carried out to make sure staff members are competent at operating snowmobiles in these harsh conditions. This is because of the significance of these vehicles. These drills make sure missions are super efficient and safe, all while boosting how ready and prepared they are for anything that comes their way. The LC-130's deployment of snowmobiles is more than just a logistical operation. It also represents the flexibility and readiness that define missions in these challenging, frigid conditions. And guess what? There's another star in the Arctic show, the Snow Panzer. This robust vehicle effortlessly cruises through the tricky terrain. All of this is part of the thrilling mission action in the bitter cold. The U.S. Army Engineer Research and Development Center, in particular the cold regions, Research and Engineering Laboratory Mobility Group, is at the forefront of the development of these vehicles. They are in charge of performing a number of maneuvers in tracked and wheeled vehicles, demonstrating incredible agility under extreme weather conditions. These drills range from crossing ice stretches to scaling snow-covered hills. They are essential for creating efficient mobility solutions, in addition to testing the capabilities of the vehicle. The knowledge that these exercises provide is essential for dealing with the different types of terrain that warfighters encounter throughout the world. The Joint Light Tactical Vehicle is a noteworthy development in military mobility, in addition to specialized snow vehicles. A family of more resilient vehicles with a larger cargo capacity is intended to partially replace the Humvee fleet. This is part of a program that is a joint venture between the U.S. Army, U.S. Marine Corps, and Special Operations Command. The JLTV program started in 2006 with preliminary research that expands upon the knowledge gained from the Future Tactical Truck Systems program. It also builds on insights gathered from other related initiatives. The High Mobility Multi-Purpose Wheeled Vehicle, also known as the Humvee, was first deployed in 1985 during the Cold War. However, threats such as asymmetric warfare and improvised explosive devices were not taken into consideration during the initial design phase. These concerns later became serious issues. It became clear that the Humvees were vulnerable to IEDs, which made armoring them effectively difficult and expensive. The JLTV was developed in response to these circumstances. As we wrap up our exploration of these extraordinary Arctic and Antarctic operations, think about the cool engineering and adaptability that make these missions possible. Which specific technological innovation showcased in the video, in your opinion, makes military operations more effective in hostile areas? Comment below.